Hey guys, it's me Dawson from Decoder. So in this I'll be explaining about machine learning. So first question you might ask yourself, well Dawson, what's machine learning? So my reply for that will be a machine learning is a type of an artificial intelligence or AI that allows the software applications to become more accurate in predicting outcomes without being explicitly programmed to do so. Machine learning algorithms use historical data as an input and predict new output values. So what happens is the algorithms in the machine learning, you take the historic data and they try to predict the future. That is, they try to predict the new output values. So recommendation engines are common use case for machine learning. Other popular uses include fraud detection, spam filtering, malware detection, business process automation, and predictive maintenance. So fraud detection in the sense you can they might be cyber criminals who might try to do some cyber fraud. So to catch to detect the cyber criminals, we can use machine learning. And next is spam filtering. You might have seen many times you might get the spam messages and all those stuff. So for that reason also machine learning is being used. Next is malware threat detection. So there might be a threat, or actually like there might be a malware threat, or there might be some kind of a virus which might try to enter your system. So to protect that we use machine learning. Like there will be even the antivirus also, they keep on updating their databases and to detect the new malware which is being evolved. So to protect all those stuff we use machine learning. So you might ask yourself now, Dawson, why is machine learning important? So machine learning is important because it gives an enterprises a view of trends in the customer behavior and the business operation patterns, as well as it supports the development of new products. Many of today's leading companies such as Facebook, Google, or Uber make use of machine learning to a central part of the operation. Machine learning has become a significant competitive differentiator for many companies. So many companies today are using machine learning pattern to analyze and to process the data so that they can become a significant competitor differentiator for many companies. So to be in this competition we use machine learning. So what are the different types of machine learning, you might ask? There is classic machine learning, often categorized on how an algorithm learns to become more accurate in its prediction. There are four basic approaches: supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. This type of algorithm data scientists use to detect to depends on what type of data to be predicted. Supervised learning, first one is supervised learning. Supervised learning, in this type of machine learning, data scientists supply algorithms with labeled training data and define the variables that they want the algorithm to access for the correlation. Both the input and the output of the algorithm are specified. So this is called as supervised learning. In this type of machine learning, data scientists supply the algorithms. They supply the algorithm to the labeled training data and define the variables they want the algorithm to access for the correlations. Next is unsupervised learning. This type of machine learning involves the algorithms that train on the unlabeled data. The algorithm scans through the data sets looking for the meaningful connection. The data that algorithm trains, as well as predictions and recommendations they output, are predetermined. So this is kind of a predetermined data. So here you can see that this type of machine learning involves algorithm that train on a unlabeled data. The data is not labeled, it is unlabeled. So the algorithm scans through the data sets looking for a meaningful connection. So it looks through the data sets and all those stuff for meaningful connection. So the data algorithm train, as well as predictions and recommendations, the output is predetermined. So the output is predetermined. Next is semi supervised learning. This approach to machine learning involves the mix of two preceding types. Data scientists may feel an algorithm mostly labeled training data, but the model is free to explore the data on its own and to develop its own understanding of the dataset. So what it means is the semi-supervised learning. This approach involves the mix of two preceding types. Data scientists feed an algorithm mostly labeled. This is labeled. In previous one it was unlabeled. I feel, yeah, it was unlabeled. Here it's labeled training data, but the model is free to explore and the data on its own and develop its own understanding of the dataset. Next is reinforcement learning. Data scientists typically use reinforcement learning to teach a machine to completely multi-step process um, to complete a multi-step process which there are clearly defined rules. Data scientists program an algorithm to complete a task and to give its positive or negative cues as it how works to complete a task. But for most part, the algorithm decides on its own on what steps to be taken on the way. So there is reinforcement learning. That is, they use reinforcement learning to teach a machine to how to complete a multi-step process to which there is clearly defined rules. So data scientist provides an data scientist program an algorithm to complete a task and to give it a positive or negative cues. Negative cues, and it works on how to complete a task. So how is supervised machine learning work? Supervised machine learning requires the data scientist to train the algorithm on both labeled inputs and desired outputs. Supervised learning algorithms are good for the following tasks: binary classification, divide the big data into two categories; multi-level classification, regressive modeling, and reassembling, combining the predictions of the multiple machine learning models to produce an accurate prediction. This is called as assembling, where there is binary classification, that is dividing the data into two categories, that is binary is 0 and 1. There is multi-class classification, that is choosing between more than two types of answers, so there is multi-class. Next is regression modeling. Regression modeling is predicting the continuous values. So next we'll move on how unstructured unsupervised machine learning work. Unsupervised machine learning algorithms do not require the data to be labeled. They sift through the unlabeled data. They look for the patterns that can be used to group data points into subsets. Most types of deep learning include neural networks that are unsupervised algorithms, that is, they are not supervised, they are unsupervised. So the unsupervised learning algorithms are good for the following tasks. There is clustering, that is splitting the dataset into groups based on the similarity. There is anomaly detection, that is identifying unusual data points on the dataset. There is associated mining, that is it's identifying the sets of items in a data that frequently occur together. There is dimensionality reduction, that is reducing the number of variables in the dataset. How does a semi-supervised learning work? Semi-supervised learning works by the data scientist feeding a small amount of labeled data, training data, into an algorithm. From this, the algorithm learns the dimensions of the dataset while they can apply to new unlabeled data. The performance of algorithm typically improves when they are trained on the labeled datasets, but labeling data can be time-consuming and expensive. Semi-supervised learning strikes in the middle ground between the performance of a supervised learning and the efficiency of unsupervised learning. So you might be confused right now. Let me make it more simple now. Semi-supervised data work by feeding small amount of labeling data into an algorithm. From the algorithm learns the dimension of the data set by which they can apply to new and unlabeled data. The performance of the algorithm typically improves when they train on the labeled data sets, but the data sets can be time consuming and expensive. So it can be time consuming and expensive. So semi supervised learning strikes a middle ground between the performance of a supervised learning and the efficiency of unsupervised learning. Some areas where semi supervised learning is used include machine translation, that is teaching an algorithm to translate a language based on less than a full dictionary of words. There is fraud detection, identifying a case of fraud when you have only few positive examples. Then there is labeling of data, that is algorithm trained on a small data sets can learn to apply the data labels to large set automatically. How does reinforcement of data work? How does the reinforcement learn work? So reinforcement learning works on the programming an algorithm with a distinct goal and the prescribed set of rules for accomplishing a goal. Data scientists also program the algorithm to seek positive rewards which it receives when it performs an action that is beneficial towards the ultimate goal, and avoid punishments which it can receive by performing an action that it gets farther away from its ultimate goal. Reinforcement learning often uses areas such as in robotics that it can so what reinforcement learning basically is, it works by the programming of an algorithm with a distinct goal and a prescribed set of rules for accomplishing a goal. So data scientists also program to seek positive rewards, and and to avoid punishment when it performs an action that gets farther away from its ultimate goals. Reinforcement learning often uses in areas such as in robotics. Robots can learn to perform a task in the physical world without using this technique. Video gameplay. Reinforcement learning has been used to teach bots to play a number of video games. Resource management. Give a finite resources with a defined goal, and reinforcement learning can help enterprises plan out on how to allocate resources. So the machine learning process diagram is as follows. Here you can see that in machine learning applications, a data scientist or an analyst identifies the relative data sets and prepares them for an analyst, chooses the type of machine learning algorithm to use, builds an analytical model based on the chosen algorithm, trains the model on the test data sets, revising it as needed, then runs the model to generate the scores and other findings. So you might ask then Dawson, who is using the machine learning and what's its use? Today, machine learning is used in a wide range of applications. Perhaps one of the best known example for machine learning is the recommendation engine that powers the Facebook's news feed. So we can see the Facebook's news feed, it uses machine learning. So Facebook uses machine learning to personalize on how each member's feed is delivered. If a member frequently stops to read a particular group post, the recommendation engine will start to show more of a group's activity earlier in the feed. Behind the scenes, the engine is attempting to reinforce known patterns in the member's online behavior. Should the member change patterns and fail to read posts at the group in the coming field, while the news feed will adjust accordingly. In addition to the recommendation engines, other uses of the machine learning include the following, that is customer relationship models, CRM softwares. They use machine learning models to analyze the email and prompt the sales term to respond the most important messages first. So more advancement can recommend potentially effective response. So in the customer relationship management, that is CRM softwares also use machine learning. Then there is business intelligence, that is BI and analytics vendors use machine learning in their software to identify potentially important data points, patterns in the data points, and anomalies. Then there is human resource information system, that is HRIS systems, that is HRIS system can use machine learning models to filter through the application and identify the best candidates for an open position. Then there is self-driving cars. So machine learning algorithms can even make it possible for semi-autonomous cars to recognize a partially visible object and to alter the driver. There is virtual assistant, that is smart assistants typically combine supervised and unsupervised machine learning models to interpret natural speech and supply context. So what are the advantages and disadvantages of machine learning? Machine learning has seen cases rising from predicting customer behavior, forming the operating system for self-driving cars. When it comes to advantages, machine learning can help enterprises understand their customers at a deeper level by collecting customer data and by correlating it with behavior over time. Machine learning algorithms can learn to associations and to help teams tailor their product development and market initiatives to a customer demand. Some companies use machine learning as a primary driver in their business models. Uber, for example, use algorithms to match drivers and riders. Even Google also uses machine learning to surface through the ride advisement in the searches. So Google AdSense also, it uses machine learning. So you can clearly see that the machine learning has its own advantages, but machine learning comes with the disadvantages. First and foremost, it can be very expensive. So machine learning processing also, it takes time. So machine learning projects are typically driven by data scientists who command the high salaries. So the machine learning projects are typically the data scientists. First of all, they charge very high. These projects also require software infrastructure that can be expensive, to be honest. So it can be very, very expensive at times. So there is also the problem of machine learning bias. That is, the algorithms that are trained on the data sets that include certain populations or contain errors that lead to inaccurate models of the world, and that at the best fail, at the worst are discriminatory. When an enterprise-based core business model process on the unbiased model, it can lead to regulatory and reputational harm. So next is how choose a right machine learning model. So the process of choosing a right machine learning model to solve a problem can be time consuming if not approached strategically. Step 1 is align the problem with the potential data inputs that should be considered for the solution. This step requires the help of data scientists and experts to have a deep understanding of the problem. So first thing is we need to align the potential data inputs that should be considered for the solution. The step requires the help of the data scientists and the experts who have a deep understanding of the problem. Next is collect the data, format it, and label the data if necessary. This step is typically led by data scientists with the help of data wranglers. Then next is choose which algorithms to use and to see how well they perform. The step usually is carried out by data scientists. So next you need to choose the algorithms which you have to use, and you need to test on how they perform. Step 4 is simple. You can continue to fine tune outputs until they reach an acceptable level of accuracy. So this step usually is carried by the data scientist with the feedback from experts who are having deep understanding of the problem. Next is importance of human interpretable machine learning. Now, explaining how a specific machine learning model works can be challenging when the model is complex. Then there is some verbal industries where the data scientists have to use simple machine learning models because it's important for the business to explain how every decision was made. This is especially true in industries with heavy compliance burdens such as banking and insurance. So complex models can be produce accurate prediction, but explaining it to a lay person on how an output determined can be can be difficult. So this we have to agree only. So what is the future of machine learning? While machine learning algorithms have in around decades, they have attained new popularity as artificial intelligence has grown in prominence. The deep learning models in particular power today's most advanced artificial intelligence AI applications. Machine learning platforms are among the enterprise technology's most competitive realms, with the most major vendors including Amazon, Google, Microsoft, IBM, and others racing towards significant customers up for platform services that cover spectrum of machine learning activities including data collection, data preparation, data classification, model building, training, and application deployment. As machine learning continues to increase its importance in the business operations and in the AI becomes more practical in enterprise settings, the machine learning platform wars will only be intensified. So continued research into deep learning and AI is increasingly processed on the developing of more general application. Today's artificial models include artificial intelligence models include extensive training and in order to produce an algorithm that is highly optimized to perform one task. But some researchers are exploring ways to create more models flexible and in the seeking technique that allows the machine to apply the context learned from one task to the future. So traditional machine learning is as such, there will be an input, there will be a feature extraction, there will be a classification, and there will be an output, whether it's a dog or not a dog. So in this case, it is a dog. Deep learning metrics uses input and it uses feature extraction plus classification, and finally the output, whether it is a dog. So here you can see there is a feature extraction plus classification. So this is called as a deep learning. So how did machine learning evolve? So 1642, Blaise Pascal, who invented the mechanical machine, can add and subtract and multiply and divide. In 1679, Gottfried Wilhelm Leibniz derived system of binary code. In 1834, Charles Babbage conceived the idea for a general all-purpose machine that could be programmed with the punch cards. Then 1872, Ada Lovelace described a sequence of operations for solving mathematical problems using Charles Babbage's theoretical punch card machine and became the first programmer. In 1847, George Boole created the Boolean logic, a form of algebra in which all the values can be reduced to a binary values can be true or false. In 1936, the English logician and cryptanalyst Alan Turing proposed the universal machine that could decipher and execute a set of instructions. He published his proof is his best on the best computer science. Next is 1952, that is Arthur Samuel created a program to help IBM computer get better at checkers at more place. Then in 1959, Madeline became the first artificial neural network applied to a real near problem that removes the echoes from the phone line. Then in 1985, Terry Sejvonis and Charles Rosenberg's artificial neural network taught itself how to correct and pronounce 200 words in 1 week. Then next was 1997, IBM's Deep Blue beat chess grandmaster Gary Kasparov. Then it was 1999, a CAD, that is computer aided design prototype intelligent workstations, reviewed 22,000 mammograms and detected the cancer and 52% more accurately than radiologists did. Then in 2006, computer scientist Geoffrey Hinton invented the term deep learning to describe the neural net research. And 2012, an unsupervised neural networking created by Google learned to recognize cats in YouTube's video with 72.848% accuracy. So you can see there was a neural network created by Google to recognize the cats in the YouTube videos with 72.8% accuracy. So next there was a chatbot which passed to the Turing test, convincing 33% of the human judges that it was a Ukrainian team named Eugen Gustman. So you can see here also they used the chatbots. Then in 2014, Google's AlphaGo, that was Google's AlphaGo, defeated the human champion Go is the more difficult game. So this was a project. I can make a dedicated video on AlphaGo, to be honest. That was Google's DeepMind project, AlphaGo, which even beat the human person also. So you can see that machine learning is indeed having a great scope and a great potential in India, not in India, yeah, throughout the globe, Uh, in 2016, LipNet, DeepMind's artificial intelligence system, identifies lip reading words in videos with an accuracy of 93.4%. Then next, 2019, Amazon controls 70% of the market share for virtual assistants in the US. So you can see there is a virtual assistants also. So the machine learning timeline, you can see the diagram here. You can see the mathematical neural networking modeling. You can see the Arthur Samuel Checker program. You can see the Frank Ruslin's perception, and you can see Donald Maclean's machine also. You can see the diagram also on how it works. Then there is the Turing test, that is Alan Turing proposed the Turing test, according to which a machine learning can convince a humans into believing that the machine is also human and termed as intelligent. Then there is Dartmouth Summer Research Project on Artificial Intelligence. So John McCurry invited many well-known mathematicians, researchers and scientists in Dartmouth College, where they brainstormed on ideas on thinking machine about 6 to 8 weeks. This event considered the birthplace of an artificial intelligence. Then in 1967, there is nearest neighbor algorithm that granted computers the capacity to the basic pattern recognition that was used to plain routers for traveling salesmen. So 1970, there was suppose Lehman and automated differentiation. So guys, yeah, so guys, this was the video. So guys, like share dislike, or like, do whatever you want. You can leave a comment also down the line, but one thing I would like to say is never stop learning. Thank you very much, guys. And if someone needs a dedicated tuition on machine learning, I'm doing currently a crash course on Google, so if anybody is interested, you can let me know. There'll be a link in the video description. Thank you very much, guys.